In order for us to talk about probability, we have to have a random occurrence, something like the rolling of a die. When you roll a die, you're never quite sure what's going to come up, provided that it's a fair die. So each roll of the die yields an unpredictable result. But based on what you know about the die, you know that each one of the faces on the die is just as likely to come up as any other. So an activity or occurrence with an observable result is called an experiment. The key thing to this term is it has to have an observable result. If we can't observe the result, then it really doesn't talk about how likely it is for something to occur. Each repetition of the experiment is called a trial. In the case of rolling a die and observing the face, each time I roll the die, that would be a trial. The possible results of each trial are called the outcomes. So when I roll the die, I could get a 1, I could get a 2, a 3, a 4, a 5, or a 6, because I'm counting the number of dots on the face. So the set of all possible outcomes is called a sample space. And here you'll see where that idea of sets comes in. So if I take all of the possible outcomes, 1, 2, 3, 4, 5, 6, and talk about them as a set, and put it in curly brackets, well, that's my sample space. And the letter we usually use to denote that is capital S. So I'll write capital S equals the set 1, 2, 3, 4, 5, 6. This tells me that's all the possible things that could happen in this possible experiment. And usually by telling me what the experiment is and telling me what the sample space, that pretty much characterizes everything in the experiment. Now an event is simply a subset of the sample space or a portion of it. If I want to talk about the event a 5 is rolled, I might call that E1. That would be the set with a single element, the number 5. When you have an event which has only a single outcome, things like that are called simple events. Well, I could also have an event an even number is rolled and call that E2. And in that case, the set would consist of 2, 4, and 6. And again, that's a subset of the sample space. It's contained within it. I could have a number less than 5 is rolled. In that case, I could call it E3, and that set would include 1, 2, 3, and 4. So like we said before, events that have only a single outcome are called simple events. If an event equals the sample space S, then that event is called a certain event. In other words, that event is certain to occur. So if you said that the event you were interested in is that you get a 1, 2, 3, 4, 5, or 6, that's certain to occur on this experiment when you roll the die. An event that has no members, that is called the impossible event. So if I said rolling a 7, there's no possible way to roll a 7, so that event would be the empty set, and since it's impossible, we'd call it the impossible event. Now if we have two events, E and F, that are mutually exclusive, that means that when I intersect those two events or see what's in common, I get the empty set. So since events are sets, like we've just seen, we can apply set operations. So let's suppose E and F are events for a sample space S. E intersection F occurs when both E and F occur. E union F occurs when E or F or both occur. The complement of E occurs when E does not occur. So what you'll notice here is these descriptions include and, or, and not, which are kind of our telltale signals for intersection, union, or complement. So let's go back to those three events, E1, E2, and E3 that I defined before. So let's talk about an event, an even number or a 5 is rolled. Even number was E2 and a 5 was rolled was E1, because when we do the union between those, we're saying that an even number or a 5 is rolled, so that is the union of those two sets, so we get 2, 4, 5, 6. If I talk about an even number and a number less than 5 is rolled, now I'm talking about and, so I'm doing intersection. That would be E2 intersected with E3. And when I take E2 and intersect it with E3, we see what's in common there is 2 and 4. And notice that both of those numbers are even numbers and they're less than 5 and still in the sample space. So now let's take a look at a new event. So an even number and an odd number is rolled. Notice that we haven't talked about odd numbers yet, so I need to define that event. The event that an odd number is rolled, we'll call that E4, and that consists of 1, 3, and 5. Now, I'm asking for and here, so I want the intersection between these two events, E2 intersected with E4. And since those events have nothing in common, that means the intersection would be the empty set. So this would be the situation when we have mutually exclusive events. 2, 4, and 6, 1, 3, and 5 are mutually exclusive because they have nothing in common. And that kind of makes sense, right? You can't have an even number and an odd number when you roll the die. So now let's take a look at a different experiment. This time I'm thinking about a random occurrence, which is the face that shows when you flip a coin. So my experiment in this case is I'm going to flip 2 coins and I'm going to observe the faces on those 2 coins. My trial is going to be each time the 2 coins are flipped, and the outcomes are going to be what appears on each face denoted with H or T. So my sample space would consist of the set of all objects HH, HT, TH, and TT. One possible event would be a head is tossed. So that would be, in this case, the event E1, and a head could be tossed on HH, HT, or TH. In each case, a head was tossed. It didn't say how many heads, it just said a head was tossed. Now another event I could talk about is the faces match, and I'm going to call that E2. So the faces match when I have HH or TT, so that event is that set with HH and TT. What if I said a head is tossed and the faces match? So as soon as you see that and there, you know I'm doing intersection. So this is going to be the intersection of E1 and E2, and what they have in common is heads, heads. So the event a head is tossed and the faces match is heads, heads. I could also talk about the event a head is tossed or the faces match. So now you see that or in there, so that means I'm doing union. So E1 union with E2. When I put all of those together, I get HH, HT, TH, and TT, and that's the entire sample space. So this particular event would be a certain event. When you toss these 2 coins, you're certain to get a head or the faces match.